Okay, so now that we have a general idea of the real numbers and how they are ordered on the real number line, we can look at pairs of numbers. So an ordered pair, say like the pair 1, comma 3. So now this should not be thought of in this context as an interval, right? An interval, if this were an interval, would be looking at all the numbers between 1 and 3, right? So we would look at this interval here. That would be an interval. But if instead we're looking at an ordered, apologize for my writing, but we're looking at an ordered pair, then what we think of is as the first entry being a real number and the second entry being a real number. Not an interval, but a pair. And so we can think of that as by putting two number lines together. So we can have, say, the first coordinate, often returned as the x-axis, and the second real number line, oftentimes referred to as the y-axis. And so we would go for the point 1, 3, 1 over in the x direction, and 1, 2, 3 up in the y direction. So this would be the point 1, 3. So it's important to kind of discuss how to tell the difference because we have duplication here. We can have this notation where we have 1 comma 3 in open parentheses, and if in the context we know that that's an interval, then we're thinking of all the numbers between 1 and 3. However, if we know from context again that screen's going crazy, from context again that we have an ordered pair, then what we're thinking of as a location in space, which is 1 unit in the horizontal direction and 3 units in the vertical direction. And of course we can have other values. 1, 3 is nothing special about it. So maybe the point -2, 1 would be about here, right? Because this is -2, -1. This is still 1. So this point here would be -2, 1. And so we have an address system in which the ordered pair tells you where along the horizontal axis and where along the vertical axis. We can also discuss how far points are apart from each other. So for instance, these 2 points that I've drawn in here, if I were to make a straight line, we know the shortest distance between 2 points is a straight line. So if I make a straight line, wow, that's so unstraight. Straight line, and ask, well, what is the length of that line? Well, we can take advantage of some geometry that we know, that we can drop a right triangle here, and this distance here is, well, vertically we're moving from the point, right, this is the point 1, 3, and we're not moving anywhere in the x direction, 1, 1. We're not moving anywhere in the x direction, but we are moving in the y direction. So this distance is 3 minus 1, or 2. Then if, on the other hand, we look at the distance between these 2 points, so we're not moving vertically, we're just moving left and right, we're moving horizontally. And so the distance between these 2 points would be, say, 1 minus 2. Right? That would give me the distance from this point in the on the x-axis to this point in the y-axis, which of course is equal to 3. So I've got a right triangle whose height is 2 and his base is 3, and we know from Pythagorean's theorem that in any right triangle, so if I have a draw a right triangle here. If I have a triangle whose hypotenuse is C, whose height is A, and base is B, then the relationship between those is that a squared plus b squared is c squared. So using that, I know that whatever this distance is here, that it's got to be equal to 2 squared plus 3 squared. Right? This distance, let's call it c. So I know that c squared, using Pythagorean's theorem, is got to equal 2 squared plus 3 squared. Or telling me that c has to be the square root. Well, 2 squared is 4, and 3 squared is 9, so 9 plus 4 is 13. So this distance between the 2 points is root 13. So let me write that out. The distance between the points -2 and just 1, between that point and the point 1, 3 is equal to square root 13. So let's talk about how to just do that in general. We can see that there's nothing special about the point 1, 3 or the point -2, 1. Nothing special about those 2 points. Well, all we did is we looked at the distance between them as if they were a hypotenuse of a right triangle. And so we just need to know what is the change in y. So that's just the change in the y coordinate, and then the change in the x coordinate. We looked at that distance, squared it, added together, and took the square root. So in general, apologize, I'm still getting the hang of, oh my goodness. Still trying to get the hang of this system. Thank you for your patience. So if I want to look at the distance, say, between a general point, some generic point, so the distance between, say, x1, y1, and the point x2, y2, then that's going to be equal to the square root coming from Pythagorean's identity. And it's going to be the distance between the x-coordinates. So I just need to take x2 minus x1 and then square it, because that's the length of the base. And then I'll add it to y2 minus y1 and square it. Again, just to remind you where these come from, we're looking at a triangle. And so if that is the hypotenuse is the distance, we call this A and B, and say this is our D for distance. Then this right here, this x2 minus x1 is actually calculating the value of A. And this value right here, y2 minus y1, is calculating the value of B. All right, we will, in the next episode, we will talk about equations for circles.